Hello, my name is Lubo, and in this video we're going to solve a really interesting math problem from the Asian International Math Olympiad. But first of all, we have to cover two theorems that will be pretty useful for us to solve the problem. So the first one is the Wilson's theorem, which states that for every prime p, this statement is true, which is p minus 1 factorial is comparable to minus 1 by modulo p. And that is pretty interesting, and in other video I can prove the theorem, but not now. And the statement that comes from this theorem is the Leibniz theorem, which is pretty similar to that, which states that if p is a prime number, then the statement that Leibniz says is true as well, which is p minus 2 factorial is comparable to 1 by modulo p. And those theorems are pretty interesting. And we're going to use them in the question itself, which is define n factorial. If you don't know what is n factorial, it is the number n multiplied by every natural number below the number to 1. I can make a video about that as well, because there are some specifics there, but today we have to check this problem. So find the remainder of 98 factorial times 98 factorial, 99 factorial times 100 factorial divided by 101. So when we write this problem in numbers language, we can say that this big number divided by 121 is equal to some number, let's say a, with remainder n, or no, not n, but remainder r, let's say, which is good, because presented this way we can apply the formulas above, which is pretty good. So for the when we lose Leibniz theorem, we can use that 99 factorial times those numbers divided by 101 gives us a remainder of 1, which is good for us. And when we apply the Wilson's theorem, 100 factorial divided by 101, this gives us minus 1 remainder, which is basically the p number minus 1, which is 100. So we get 100 remainder, because as you know, we can't have a bigger remainder than the divisor. And the issue we have to solve now is what is the remainder of 98 factorial divided by 101, because when we understand and when we know what is the remainder of that, we can solve the exact problem. And what we got from the equation above that I deleted is this one. And when we have to see what is going to happen with 98 factorial, we have to simply write 98 factorial, which is comparable to r, let's say, which is comparable to x, because r factorial will be the final answer, and that's solved by modulo 101. What we can do now is simply multiply by 99, which from the left hand side of the equation will give us 99 factorial, sorry, which is comparable to 99x by modulo 101. We can use the Leibniz theorem now and say that 99 factorial is comparable to 1 by modulo 101. And from that statement we can say that 99 x, which is the remainder, minus 1 is equal to 101 one other number, let's say y. And we have a Diophant equation, so if you want you can skip how to solve it, but I'm going to write a solution for that. There are many ways you can solve a Diophant equation. I will use a method that is pretty easy to understand. So from that statement we say that x is 101y plus 1 over 99, which is equal to y. We get the whole part of the fraction, which is equal to y plus 2y plus 1 over 99. This gives us the statement that if y is a whole number, x is a whole number, then this fraction is a whole number as well. So we can just rewrite it like 2. Now make a arrow. 2y plus 1 is equal to 99 another letter, let's say t. From that statement we can say that y is equal to 99 t minus 1 over 2, and when we get the whole part from that as well, because y is a whole number, we can say that 49 t plus t minus 1 over 2 is y, and 49t is a whole number, as we can see, so t minus 1 over 2 is a whole number as well, and we just have to rewrite this one. So t minus 1 over 2 let's say is equal to v, it doesn't matter, and from that we can say that t minus 1 is equal to 2 times v, from which we can state that t is equal to 2v plus 1. And this is a good thing to know, because now we can apply these things, because we don't have fractions now, and we can simply rewrite the statements above to show how this works. And when we have t, we can express the y, and when we know the y, we can express the x, and from that we can solve pretty much the equation. And from that we can state that y is equal to, I will put an arrow here, and y is equal to 49 times 2v plus 1 plus 2v plus 1 minus 1 over 2. I'll put brackets in here, which is simply 98 v plus 49. 1 minus 1 is 0, 2v over 2 is v, so 98v plus 49 plus v, which is 99 times v plus 49. I should have addressed earlier, but v is a whole number as well. It doesn't have to be natural, of course, so we can put it 0, and from that we can say from now on, even though we don't know the x, that y is 0, that y is 49, because when we put v to be 0, we can solve the problem. From that we can say how much is x, and x is going to be 101 y, which is 101 times 99 v plus 49 plus 1 over 99. As we know, this must be a whole number, so we don't have to panic. And when we unveil the brackets, we have 99,999 v plus 49 plus 1, which is 4,950 over 99. And from that we know that both numbers can be divided by 99, so we can just write simply 101 v plus 50, because 450 can be divided by 99. Simple as that. And from these statements we can say how much are x and y. Of course, x, we need x right now, is going to be 50, and y is going to be 49. When you apply that, v is a real number and it can be 0. And when we go above in the statement, and from this statement here, we can simply say, you can write an arrow and say that 98 factorial divided by 101 have a remainder of 50. So we get 50 times 1 times 100, which is, when we divide it by 101, we should get the remainder we want. And when we apply the 550 times 100, which is 5,000, divided by 101, we get a number. And when we solve this equation here, we get that r is 51, and this is the problem we want to solve. And that's it from me for that question. It was pretty interesting to check those formulas and apply them in the problem. I think that there can be more solutions to that problem, not just by those two formulas and the Diophant equation. Of course, the Diophant equation can be solved by many other ways, much faster than I did it. However, it was pretty interesting. I hope you liked the video. If you like it, you can leave a like, leave a comment. If you want to support me, you can subscribe to the channel and expect more videos in the near future. Thanks for watching.